YouTube, in this video we're going to look at a situation in which we can use square roots to help us kind of interpret a non-function as a graph on a graphing calculator. So let's just go ahead and take a look at this example here in which we have x squared plus y squared equals 49, and basically what we want to do is graph this on a graphing calculator. The issue here is simply this. We say when you graph something on a graphing calculator, at least a function here, y is a function of x, you would have to write it as y equals in a y equals form first. So here's where the square root part of this video comes in. If we were to solve this equation for y so that we could plug it into our graphing calculator, what happens is we end up isolating the y squared part first. So we're going to subtract x squared from both sides. So we get y squared equals 49 minus x squared. And then our next natural move here would be to take the square root of both sides. Now the interesting thing here is that we get y equals and the square root of 49 minus x squared. But recall that when you take the square root of a value here, you get both a positive and a negative result. And so what we're going to say here is that this function right here is the same as the original function, but where we've solved for y to begin with. So we're going to put this into our graphing calculator. So we'll start with this. We're going to put in the square root of, and we get 49. So we say 49 minus x to the second power. And we have to end this parenthesis here so it captures all this. The interesting thing is on the very next line, let's go down to y2. And what we're really going to do is this. We're going to plug in for y1, we're going to put the square root of 49 minus x squared. And then for y2, what we're going to put is the square root of 49 minus x squared, but where we have the negative outputs. And so when we put this in here, we're going to start with a negative here. And then we just say really the same thing we just had typed in on the line above it. Whoops, let me go back here. The square root of 49 minus x to the second power, end parenthesis. And so when I hit graph here, what you see is we get this graph that does this right here. And because our graph, it actually gets it gets vertical here at let's see, 1, 2, 3, 4, 5, 6, 7. It gets vertical out at positive 7 and negative 7. This is actually really, believe it or not, the graph of a circle. And in terms of identify the radius, we could look here. We say 1, 2, counting upward, 3, 4, 5, 6, 7. It goes up 7 and the right 7 and the left 7 and down 7. So we would say that the radius has a length of 7. Length of 7 units. And this is the graph of a circle. Cheers.